We're going to look at the product rule and the quotient rule. So I'm going to do examples here, and then I'll do a bunch more after we've established the rules. So product rule is if we have two functions that are being multiplied together. So we can't just take the derivatives of them and multiply them like we could with the limits, right? If two functions were multiplied, we could piece it together and say, hey, the limit of one and then the limit of the other, and then we can multiply them. That's not the same for derivatives. So there's a whole rule we have here. So we take the one of the functions and multiply it by the derivative of the other, and then we switch it. We take the other function and multiply it by the other derivative. Now that's like a whole mouthful. And I could say, okay, f of x times g prime of x plus g prime of x, or g of x times f prime of x. And that's just like a lot. So the way I remember it is left d right plus right d left. Okay? And I think that's a lot easier to work with. Addition is commutative, so you can do right times the derivative of the left times the derivative of the right. But I don't know. My teacher in high school said left d right plus right d left, and that was rolled off the tongue. So let's apply it. So this is my left function. This is my right function. You could, off to the side, do L prime and R prime and substitute in. So L prime is 2, R prime is 1. And then do a substitution so that F prime is left times derivative of the right plus right times the derivative of the left. And then we can clean it up. So 2x minus 1 times 1 is 2x minus 1. Oops. And then x minus 4 times 2 is 2x minus 8. So then we have 4x minus 9, right? Let's try it again for this one. So left, x squared plus 3x minus 1 times the derivative of the right, so 4x, and then plus the right, so 2x squared minus 5 times the derivative of the left, so 2x plus 3. And then I would try and distribute this out just to see if any like terms can combine. So 4x cubed plus 12x squared minus 4x. I'll have to do some foiling or some double distributing here for this one. So I'll get 4x cubed plus 6x squared minus 10x minus 15. And then I think I have some things that are like terms that I can combine. So 8x cubed plus 18x squared minus 14x minus 15. All right, we'll do some more practice here in a couple minutes. Let's look at the quotient rule. So before, we might have seen functions that might have been like this. We might have had, I don't know, 2x squared plus 3x minus 1 all over x. And before the quotient rule, we would try to simplify that, right? That could be 2x plus 3 minus 1 over x. And we could use our normal power rules to get the derivative here. So what if the denominator is not something that can be divided out of each one? So maybe we have a whole function like x minus 1. We can't simplify like I just tried to do. So we have to do the quotient rule. Now I do have a less of a mouthful to say other than this rule as it is, right? So I have g of x times f prime of x minus f of x times g prime of x all over g of x squared, right? I was always taught low d high minus high d low all over low low. And so that's how I remember that. So let's go through these two. So I have low d high. So low function, x minus 5, times the derivative of the top. So 6x squared plus 8x minus, and then I throw a big bracket over this second part because I'm subtracting off the entire quantity and I don't want to miss distributing my negative. So I throw a big bracket over it to remind myself, like, hey, I have to distribute this negative. So low d high minus high times the derivative of the low, which is just going to be 1, and then all over low, low. And then we'll try and clean it up here. See if we can combine any like terms. So that's what? 6x cubed plus 8x squared. I'm going to rewrite that 3 a little nicer. And then minus 30x squared minus 40x. Luckily, this quantity times 1 is just itself, so I just need to distribute that negative. So minus 2x cubed minus 4x squared plus 7 all over x minus 5 squared. And then we'll do some like terms if we have any. So let's see, 6 minus 2 is 4, so 4x cubed, 8 minus 30, and then minus 4 gives me negative 26x squared. And then minus 40x plus 7 all over x minus 5 squared. I don't think that top is going to factor into anything that will be able to cancel with my denominator, so I'm going to leave it as it is here. I'm going to move to B. So I've got low d high minus high d low all over low, low. And then we'll clean it up. So 12x squared plus 4x minus 6x squared all over 3x plus 1 squared. It's going to give me 6x squared plus 4 all over 3x plus 1 squared. Oh, that's a 4x. I can take out a GCF of what, 2x, and be left with 3x plus 2. But that does not cancel anything in the denominator, so I can leave it as this. Or since I already did factor it, I could leave it in its factored form as well. All right, let's look at some more examples here. So some of these might be easier to distribute and do power rule than it is to do left d right plus right d left. So let's just see. This one I probably wouldn't multiply out, so we'll just do product rule. So left d right plus right d left. And then let's distribute, see if anything will combine nicely. So we get 8x to the negative 3 plus 16x plus 4 pi. And then we'd have, oh, that would be a minus 24x to the negative 3 plus 16x minus 6x to the negative 4 plus 4. And I think we have some things that can combine. Right, 8 minus 24 is going to be negative 16x to the negative 3. 16x and 16x will make 32x. I've got a negative 6x to the negative 4. And then my 4 pi and plus 4. And I think I would probably leave that because factoring out a 2 or factoring out a -2 isn't going to make it, to me, any cleaner. So I can leave it. Could put it in standard form if we really want to be super proper. But I would leave it. All right, here's where maybe I wouldn't do product rule just because there's one term here. So what if I make that x to the 1/2 times 3x squared minus 3 and then just distribute, right? We can add the exponents. So 2 plus 1/2 is 2.5. So let's make that 5/2. And minus 3x to the 1/2. And then do power rule from there. So that's going to be 15/2 x to 3/2 minus 3/2 x to the -1/2. And I think that is fine. Let's do some quotient rule ones here. So we have low d high minus high d low all over low low. So 2x plus 1 minus, I'm just going to go ahead and distribute. It's going to be 2x, and then I have a -10, so minus -10 would be plus 10 over 2x plus 1 squared, which the 2x's will cancel out, so I'm left with 11 over 2x plus 1 squared. Right? And for here, same thing. I have one term in the denominator, so maybe I could simplify, because 1 minus 1/2 is just 1/2. And then we can make that t to the -1/2, so that the derivative is 1/2 t to the -1/2 minus 1/2 t to the -3/2. And that was a little bit more efficient and quicker than if I did quotient rule, right? But let's just practice quotient rule again here, right? Always good practice. So low times d high, which that would be x to the -1. So if I do my derivative, it's actually going to be just x to the -2. So low d high minus high d low all over low low. I'm going to distribute. So that's going to be x to the -1 minus 3x to the -2 minus 2 plus, and I'm going to make that x to the -1 because you're going to see what's going to happen here when I combine some like terms. And then we have x minus 3 squared. So x to the -1 plus x to the -1 is 2x to the -1. And then we have minus 3x to the -2 minus 2 all over x minus 3 squared. Right. So here's another one where maybe we can get out of doing the quotient rule by simplifying. I'm going to do both just for the fun of it. So I'll separate it here. So let's simplify. 6x squared over 3x is 2x. 3x over 3x is 1. And then we'll make that a 5/3 x to the -1. So if I do just the derivative of that, I get 2, and well 0, and then plus 5/3 x to the -2, right? And then let's do quotient rule. So low d high, I don't know why I put 3, that should be 12. Low d high minus high d low all over low, low. So that's going to be 36x squared plus 9x minus 18x squared minus 9x plus 15 all over, let's just go ahead and make that a 9x squared. Can combine some like terms, so 18x squared, the x's will cancel, plus 15 over 9x squared. And then if I were to simplify that even further, it's going to leave me with 2 and then 15/9 x squared down here. 15/9, I could reduce that even further. Divide them both by 3, 5/3, and that would be x to the -2, right? So it's a little bit more efficient to simplify first. Right. Right, few more here. So product rule, left d right plus right d left. And then, we could do a GCF. Nothing's going to cancel out. So we can try. Let's pull out an x squared e to the x. So then I would be left with x plus 3. Now, if we had a denominator, maybe that would have been helpful to cancel some stuff out. I don't know. But two versions of the same answer. Let's do this one. Left d right plus right d left. I could probably clean this up and say e to the x over x plus e to the x natural log of x. If we wanted to pull a GCF of e to the x out, that'd be 1 over x plus natural log of x. You can argue which one looks nicer, but same thing. Let's go a little bit further. So we have a function. Find the equation of the tangent line at x equals 4. So to find a tangent line, I just need a point and a slope. So I know I can find my slope by doing the derivative at a point. Let's just finish out what the point is. So I know 4 is the x value, so let's find the y value. So g of 4. So 4 squared minus 5 times 3 times 4 plus 2. And for space, I'll just go sideways here. So 16 minus 5 is going to be 11. And then 12 plus 2 is 14, right? So then 11 times 14 is 154. So there's my point. And now I need my derivative. Let's just go ahead and do product rule. So left d right plus right d left. Could simplify it further. So 3x squared minus 15 plus 6x squared plus 4x. 9x squared plus 4x minus 15, and then we can plug in 4. So we can get our slope. So let's see, 16 times 9. These are really big numbers here. So 144 plus 16 minus 15 is going to be 145, and that's our slope. So y equals the slope, x minus the x value plus the y value. And all right, that was it. So if you have any questions, let me know.